Hi everyone, it's Sorkin. Today we have a problem when we are given an array nums and we are given a value k. So at each step we are starting from the beginning of our array. We can move k steps. So for example, in this case we can move starting from the first 0 index. We can move either 1 step or 2 steps, and we need to reach the end of the array with the maximum value. So for example, in this case, let's say that we have a value max. So each index has its own value, and we are starting from the first index. If we are starting from the first index, our value is 10, and now we can go either 1 step or 2 steps, right? So we can go either to the first index, or we can go to the second index. We are going to the second index because if we go to the first index, the value would be 5, and if we go to the second index, then our value is 15, so we are going to the second index. And the same is the last one. So we can reach the last index, right? We can reach either from the first index or from the second index. Reaching from the first index, the value would be 7, and reaching from the second index, the value would be 17, which we are returning. So how we are going to solve this problem? We are going to use dynamic programming bottom-up approach. So what is the dynamic programming? Let's first remind ourselves. Dynamic programming is that we are dividing a problem into small sub-problems. First we are solving a sub-problem, and then we are building up to our solution. So for example, in this case, let's assume that we have only one element. Let's say that we have only one, right? Let's say we have only one element in our array nums. If we have only 10, then the max value is 10. So if we have two elements, then the maximum value of reaching to the first index is first index plus second index, right? Because we have to make one step, and the value is 5. So the max value of reaching to the first index is 5. So how about the third one? For the third one, either we can reach the first index, right? Either we can reach from the second index, either we can reach from the 0 index, or we can reach from the first index, right? Or we can reach from the first index. So for that, the value of that is, so we are comparing, we are taking the maximum value of 10 plus 5 or 5 plus 5, so 15 and 10, right? So 15 more than 10. So we reach the second index from the 0 index, because in that case we are getting the maximum value. So how about the last one? For the last one, again, the k is equals to 2, so which means that we may either reach the last index from the first index, or we can reach from the second index. So 5 plus 2 is 7, or 15 plus 2 is 17. So we are comparing 17 and 17 and 7, and the max value is 17, so we are taking 17 and we are returning that value. So what's the problem with this approach? We can solve this problem using dynamic programming, but we need to do one more improvement. The improvement is that at each step we are going k steps back, and we are checking each value k steps back. So we only need the largest element from the I minus k to the I. So for example, in this case, let's say that we are at the last index, right? And we are making a decision. So we need to pick the value from the I minus k. So we need to go k steps back, right? So we need to take the largest value from I minus k to the I. So whatever the largest value plus our value of our current value. So what we are going to do for that, in order to not to go back to k steps, because in our case, k is equals to 2, but we may have a case when the k is equals to 50, and which means that for every case, we need to go back that many steps. So in order not to do that, we are going to use a dequeue, where we are going to store the max value from I minus k to the I. So at each step we are going to exclude the last element, right? The leftmost element, and we are going to keep only the maximum element within that window. First thing that we do here, we are creating an array dynamic programming with the size of our nums array. And the first one is that for the value of the 0, we are setting the value of the num 0. So for example, let's say if we have only one element, right, then the value of that, the maximum value of that will be whatever that value is. The next one is we are creating a DQ, and in the DQ we are not storing the values, but we are storing the indexes. So we are adding our first index to the DQ. Let's take this example. Let's say that we have an array 5, 10, 5, 5, 2, and our k is equals to 2. And for the dynamic programming, right, the first one we are storing at the 0 index, the value is whatever the value is in our array. For the second one, so we can for this first index, we can reach the first index only from the 0 index. So 10 plus 5, 15, it's the value. So let's say that we are making a decision for the second index right here. For the second index, what we do is we are taking the value, whatever our current value, which is 5, right, at the second index, and plus whatever our current value, plus we are taking that from the DP, we are taking the DQ, that whatever the index is at the 0 position. So at the 0 position, we will have the index with the largest value. So let's go and see why we will have at the 0 index the largest value. So first thing that we do here in our DQ, so we are removing all the indexes that are less than our I minus k. So we only considering the indexes that are so we can go only k steps back, right? So which means that we are only considering the indexes that are I minus k to the I. So whatever is less than that, we are removing those, we are popping those indexes or removing those indexes from our DQ. And for our DQ, for the next one is that we are checking that for example, let's say that the value of 20, right? So in this case, the value 15 plus 5 is 20. So for the DP third, we are storing 20. So now we have these two elements, right? In the DQ, we are checking that so for the next index, for the third index, when we are making a decision, we need to only consider these two, right? Because the k is equals to 2, k minus I minus k to I. So we need to consider only these two indexes, the value in these two indexes, and then we need to keep the largest one. So at this step, we are checking that at each step we are checking if the DPI, so in our case it's 20, so whatever the value is less than that, so in our case 15 is less than that, let's say our k is 5, 10 or whatever, so all the values that are less than that, we are removing them. We are only keeping the largest value in our DQ, because let's say that all the other values, we will not consider them anyway, so we are popping all of them from our DQ. And at the end, once we exit these two loops, we are adding our current index to our DQ. And at the end, once we exit this for loop, we are just returning the latest value in our DP, which, for example, in our case, it will be 20 and it will be 22, which we are returning. Again, the only way we can solve this problem, we are breaking down to the two smaller subproblems. First, we are solving subproblems, then we are building up to our solution. And in order not to go the k steps back for each step, right, we are using a DQ to retain the largest element within that window from I minus k to the I. Okay, what's the time and space complexity for this solution? We are going over our array only once, so our time complexity is of n, and our space complexity is we are using dp, which is the size of n. It's also the of n. Okay, that's it for today. I also have identical solution in Java. I will add that into description. That's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.